Hello students, I am Saptarshi, your electronic mentor, and I'm back with the V2 of PN junction. The first subtopic of PN junction is biasing. PN junction diode has two poles or electrodes. This gives its name as di, means two, and ode, that is shortening of electrode. One electrode is termed as anode, positive, while other is termed as cathode, negative. For current to flow across the PN junction, the diode must be forward biased. The PN junction of diode acts as a switch. Under forward bias, it acts as on, and under reversed bias, it acts as off. You heard the term forward bias. What is it? The anode P-type is connected to the positive terminal and cathode N-type is connected to the negative terminal of the external source. Anode is positively charged electrode and it supplies holes to the device. Also, the positive charge carriers or the holes begin their journey at the anode terminal and travel through the diode engrossed at a cathode terminal. Cathode is negatively charged electrode. It supplies free electrons to the device. The source of free electrons travels and it gets engrossed at the anode terminal. We know the free electrons are attracted towards the anode or the positive terminals while the holes are attracted to the cathode or negative terminal. The energy band diagram for the forward biased condition is shown in this figure. Initially, at a lower voltage level, the barrier potential and the height are high, and at this point, a small number of electrons and holes flow through the device. Now, increase in voltage cause in lifting of the barrier potential and its height. Both the band of P side and N side come at an equivalent position, and at this stage, large number of free electrons and holes flow through the device easily. That was all for forward bias. Now let us study about reverse bias. The anode P-type is connected to negative terminal and cathode N-type is connected to positive terminal. As the anode is negative, it supplies free electrons to the PN junction. It is the source of free electrons. These free electrons fill the large number of holes in the P-type semiconductor. Holes in the P-type semiconductor gets attracted towards the negative terminal. The free electrons from the negative terminal cannot move towards the positive terminal due to the wide depletion region at the PN junction. From the energy diagram, we can see the cathode or the positive terminal supplies holes to the PN junction. It is the source of holes that they occupy the position of electron in the N-type semiconductor. Free electrons in the N side engross towards the positive terminal, and the electrons and the holes are unable to move towards the negative terminal because the wide depletion region at the PN junction which opposes the flow of holes. That was all for PN junction segment 2. We will continue with PN junction in our next video. Today we studied biasing of PN junction, forward bias condition, circuit diagram of forward bias, energy band structure during forward bias condition, reverse bias condition, circuit diagram of reverse bias, energy band structure during reverse bias condition. That was all. Bye bye for now. Keep watching, keep learning.